Welcome back to the deep dive. Today, we are taking, I think, a really massive leap forward in how we all understand and actually use artificial intelligence. If you've been following the AI space for any amount of time, you've probably moved past that initial, wow phase, the write me a limerick about my dog stage, and you're now grappling with what these systems can really do.
That's so true. For so many people, the mental image of AI is still um, this powerful conversational partner, a really, really skilled information synthesizer. But the fundamental shift we're getting into today is when the AI stops being just a conversation engine, and it starts becoming what we call an action-oriented digital worker.
That's a great
It's the
phrase.
difference between asking someone for advice on how to fix a car and just handing them the keys and the tools to do the whole job.
Right. And our mission today is really laser focused on that idea. We are unpacking the specific built-in tools that fundamentally change what an AI agent can do. We're looking at uh, the technological architecture that transforms this huge static text model into a functional, dynamic digital collaborator. And the crucial insight, I think, is that a highly capable agent is, well, it's essentially a master tool user.
That foundational concept is the most important thing for you to take away right at the start. An AI agent becomes truly powerful only when it can use tools. I mean, think about any professional environment. A human worker who can only talk about a financial problem is pretty ineffective, right? Especially compared to one who has access to Excel, a secure API for stock data, a legal database, and, I don't know, a little scheduling system.
A whole toolkit.
An entire toolkit. The capabilities we're diving into today, and we have 10 specific powerful internal functions. They are the digital equivalent of that entire enterprise toolkit. They turn a general model into a comprehensive, action-oriented development platform.
And we really need to get into the mechanics of these tools because just listing them off doesn't do them justice. I mean, if we're talking about a tool that generates a spreadsheet, we need to know, does it include the formulas? If we're talking about searching documents, how does it get around the limits of context windows? We have a lot of ground to cover. So let's begin with that first essential segment, the information layer. Before an agent can do anything, schedule, draft, design, it needs robust, reliable, and crucially, up-to-date information. Okay, let's unpack this. A standard large language model, it's born with this massive Achilles heel. Its knowledge is completely frozen in time. So the very first tool the agent needs is a way to look outside its own training data and access the world as it is right now.
And that's the web tool. It is the agent's essential tethered to the present moment. As you said, traditional LLMs suffer from a knowledge cutoff. If the model was trained up to, say, early 2023, anything that happened since then it's invisible to it, a total blind spot.
Which makes the output completely useless for anything time sensitive. If I ask it to draft a policy recommendation based on the current regulatory environment, but it misses a critical ruling from last week, well, the document it gives me isn't just flawed, it's potentially reckless.
It's dangerous.
Mhm.
Precisely. The web tool directly addresses this. It executes a real-time search query, effectively bypassing that static internal knowledge base.
The stuff it was trained on, yeah.
Right. And it pulls in updated information directly from the internet. You have to think about professional domains where the reliability and timeliness of information are just absolutely paramount. Fields like finance, legal, and compliance.
Okay, let's take legal research. We're not just looking for old, established precedents. A lawyer needs the absolute latest case law, the most recent judgments for citations, and they need to verify that those rulings haven't been appealed or overturned.
The value here is all about verification and currency. Imagine you're working on a tax document. You have to know the current rate. And you have to know whether a specific administrative notification, a policy amendment or an exemption order, has been withdrawn or superseded. And this requires the agent not just to find the document, but to verify the status of that document right now. That often means cross-referencing multiple government sources at the same time.
Okay, but here's a challenge I see. If the agent is basically using a search engine, how deep can its research really be? I mean, is it just relying on the first 5 results from Google, or is it capable of going into, say, deep web sources, paying for journal access, or performing these complex semantic searches that require filtering out a massive amount of noise?
That's a really important critical check. And the advanced web tool, it goes far beyond just simple keyword searching. It uses the context of your prompt to formulate highly specific nuanced queries. Often it's synthesizing multiple search strings at once to drill down past those superficial landing pages. Furthermore, the agent integrates a capability sometimes called web traversal or a source citation validation.
What does that mean exactly?
It means it uses multiple sources to verify facts. It minimizes reliance on a single, potentially biased or outdated link. For something like business intelligence, this means extracting fresh, verified market data or confirming a competitor's pricing models in just minutes. This shift, it turns the AI from a historian into a highly efficient, accountable, real-time journalist.
So in essence, the web tool gets rid of that primary source of liability for AI outputs in time-sensitive fields. By ensuring the information is current and it's cross-verified, it allows the agent to function reliably in these dynamic professional environments. It's really the foundation of trustworthy execution. And this is where it gets really interesting because now we move from just gathering text information to actively performing complex mathematical operations and creating structured assets, the Python tool. This turns the agent into a mathematician, a data analyst, and a file generator all at once.
Mhm.
But how does the AI go from describing data analysis to actually performing it? What's the mechanism for that leap?
The mechanism is an internal, secure, what's called a sandbox execution environment. So when you prompt the agent to analyze data, instead of trying to internally simulate the math within its language model architecture, the agent writes and then executes actual Python code inside a controlled virtual machine. This lets it leverage the power of specialized libraries that have been developed over decades.
Okay, so it's not reinventing the wheel. It's not rewriting NumPy or Pandas. It's generating the commands to tell those libraries what to do with the data.
Precisely. It's the computational engine, and it's powered by industry-standard data science packages. The source material highlights its dual purpose. One, executing Python code for rigorous calculations and statistical analysis, and two, generating standardized business files. Without this tool, the agent can describe data analysis, but it can't run the numbers itself. And it certainly can't generate the output in a format that's usable by the rest of the business world.
Let's focus on the practical application there. Analyzing numeric data, statistical insights, simulating complex workflows. This sounds like the agent can handle large data sets that a user uploads and derive real scientific meaning from them.
Absolutely. And the output is where the power truly is. It moves past just text summaries and into structured visualizations. It can create complex visuals like regression analysis graphs, scatter plots, or even KPI dashboards. For research reports, scientific analysis, and especially for accounting and taxation, this is just non-negotiable.
Wait, I have to pause on the file generation capability. The examples are very specific. Generating a full tax computation sheet or creating a CRM Excel file. So if the agent creates the actual XLSX file, does that file contain the underlying formulas? Or is it just the calculated static output? Because that makes a huge difference for auditing and for any future modification.
That is the defining line between a useful tool and just a novelty. And yes, the advanced Python tool generates structured files that are fully functional, meaning they often do contain the underlying formulas and data links that are necessary for auditability. So if the agent is running, say, a depreciation schedule or a tax calculation, the generated spreadsheet is not just a picture of the result, it is a live document that contains the logic it executed. This is absolutely critical for internal compliance and for external auditing.
So what's fascinating here is the implication of generating these structured data files, TDF, DOCX, XLSX, CSV. This capability lets the agent fit directly into existing regulated business workflows. I mean, accounting systems and regulatory bodies, they don't read conversational summaries, they read structured files. The agent is acting like an automated data transformation pipe, turning raw input into a ready-to-use business asset.
And if we connect this to the bigger picture, the Python tool gives the agent the ability to produce provable, auditable, and structured output. So if you're a consultant, the agent can use the web tool to get the current salary benchmarks, use the Python tool to calculate the total compensation projection based on those numbers, and then output that entire analysis as a perfectly formatted, auditable XLSX file, totally ready for the client presentation.
We've covered finding new, external facts with the web tool and crunching numbers or generating files with the Python tool. Now we pivot to understanding the knowledge the user already has. This is the file search tool, or what the source material very aptly calls document intelligence.
This is the ability to internally search and deeply analyze documents that you have uploaded. This could be a single, massive 1,000-page regulatory filing, or it could be a repository of hundreds of separate internal policy manuals.
What makes this deep reading so different from just pasting the text into the main prompt window? Because we all know that standard models just choke on anything beyond a few thousand words.
This is where we need to get into the underlying mechanism a bit. It's called Retrieval Augmented Generation, or RE architecture. When you upload a document, the file search tool doesn't just store the PDF. It breaks the document into smaller chunks and indexes them. often using what's called a vector database. So when you ask a question, the agent doesn't send the entire document to the main LLM. Instead, it first searches its index for the most semantically relevant chunks of text. That's the high-precision extraction. And then it feeds only those small relevant snippets back into the LLM as context to generate the final answer.
That's the key. It overcomes the token limit constraint by only feeding the most critical 1% of the information to the language model. A smart filter, basically.
Exactly. And this allows for incredibly high precision extraction. The agent isn't just regurgitating paragraphs. It's designed to pull out highly specific, critical data points. Think about legal work. Pulling specific citations, extracting exact clauses from complex contracts, or identifying contradictions between documents, say, conflicting policies from different departmental manuals.
That's invaluable for any field that's just drowning in documentation. Lawyers are the textbook example here. The source material mentioned extracting the ratios from judgments. For those of us who are less versed in legal jargon, what exactly is the ratio and why is extracting it so complex?
So the ratio decidendi is the binding legal principle. It's the core reasoning, or the rule of law, upon which a judicial decision is based. It's not the summary of the facts or the final verdict, it's the conceptual foundation. And extracting the ratio is complex because it's often buried within paragraphs and paragraphs of discussion, context, and secondary commentary. The file search tool is powerful enough to isolate that core principle, which makes a quick case review actually possible.
And this obviously benefits anyone dealing with mountains of proprietary policy papers, students reviewing thousands of pages of assigned reading, or compliance officers trying to ensure all departmental procedures align with the master compliance document.
The file search tool provides that necessary organizational architecture and deep analysis capability. It lets the agent manage its internal context based on your proprietary or uploaded data. This makes the agent an expert on your documents, rather than just on its general training set. It turns disorganized data into searchable, actionable knowledge.
So, to summarize this entire first section, this information layer arms the agent with everything it needs for robust input. You've got the web tool for up-to-date external knowledge, the Python tool for internal computation and structured output, and the file search tool for mastering complex proprietary documents. A truly intelligent action worker must first be an expert researcher and data processor.
And now we shift gears completely. We have established how the agent processes information and gains expert knowledge. Section 2 was all about transforming that knowledge into tangible output, managing massive creation projects, and automating tasks. This is where the digital worker really earns its title, in what we're calling the action layer.
Let's start with creation at scale. The Canmore tool is described as the agent's internal word processor, designed specifically for these massive multi-part projects. This is where we need to dive into the technical side a bit. What is the Canmore tool solving that a standard chat interface just cannot?
It is solving the problem of context window management, especially for long-term projects. As a conversation grows longer and longer, the context window, which is the memory available to the LLM, it eventually fills up. And that causes the model to forget earlier instructions or even entire chapters of what it's working on. The Canmore tool functions as the AI's persistent internal scratchpad or outline manager.
So it's not just trying to write a 500-page book in one massive block of text. It's systematically managing the structure.
Exactly. It allows the user to create, store, and edit long, multi-section documents inside the AI environment. And it maintains continuity and structural integrity over days or weeks or even months of work. Its capabilities are structured specifically for these large projects, writing entire volumes, full books, comprehensive legal arguments, or complex course curricula.
And this is so crucial for consistency. If I am writing a multi-volume textbook on, say, advanced physics, the Canmore tool would ensure that the terminology defined in Chapter 1 is automatically referenced and used consistently in Chapter 15, even if Chapter 1 was written 3 months ago.
Furthermore, it handles the complex structure itself. You can instruct the agent to edit specific pages, to merge chapters, reformat sections, or even restructure the entire table of contents without losing the content. It's vital for things like legal drafts. Think of a 200-page writ petition that requires precise formatting, numbered clauses, and appendices.
The examples are really compelling, writing entire volumes on complex subjects like Islamic jurisprudence, which requires meticulous structuring, cross-referencing, and adherence to specific scholarly formats. It seems like the tool for professional authors, legal teams, and educators who need structured, scalable content generation.
And we have to emphasize version history. For any collaborative or long-term project, whether you are an author or a legal firm, tracking changes and iterations is just non-negotiable. The Canmore tool maintains that history, which turns the agent into a viable collaborator for massive writing projects. It effectively solves that long context problem that's inherent in base models.
Action isn't purely about text, though, it's about communication. And communication so often requires visual engagement. The image gen tool integrates high-level design programmability directly into the agent's workflow. This is a massive integration of capabilities.
It is, because it means the agent can manage the entire content pipeline from a textual idea to the final presentation assets. We all know that professional communication demands visual aids, whether it's for marketing, education, or operational reporting.
I'm looking at the output capabilities here. They range from the utilitarian, like diagrams and infographics, to explain complex data from the Python tool, all the way to branding essentials book covers, logos, posters, and banners.
For authors, marketers, YouTubers, and teachers, this just eliminates workflow bottlenecks. If an author uses the Canmore tool to draft a book, they can immediately use the Image Gen tool, which often leverages integrated specialized models like Dale to create the cover art or the promotional banners. It means one digital worker is handling the entire creative chain.
I'm curious about the translation layer here. If I prompt the agent using its BioTool memory, which remembers my brand voice, and I tell it to create the artwork for a podcast called Courtroom Stories, how does the agent translate that abstract conceptual instruction into a concrete, professional, visual asset?
That's a great question. The agent translates the abstract into technical prompt language for the image generation model. It draws on its massive training data set of aesthetic principles and historical visuals associated with words like courtroom, justice, and stories, while also cross-referencing that with your defined style, which might be dark, minimalist, or vintage. The agent's expertise here is turning human language and existing style profiles into these highly optimized visual prompts, ensuring the resulting image is professional and on-brand.
So if we connect this to the bigger picture, it sort of democratizes design. It means that an expert in, say, environmental policy who has zero skill in graphic design can now produce visually competent policy briefings or infographics or social media assets that amplify their core message without ever leaving the AI environment.
We've established how the agent creates content and visuals. Now we need the agent to manage the tasks related to that content and to handle ongoing operational maintenance. This is the automations tool. This is the difference between a reactive assistant and a proactive manager.
This is the tool that fundamentally changes the user experience from I have to prompt the AI every time to the AI proactively tells me what it has completed. So it's handling setting reminders, managing schedules, and overseeing recurring compliance workflows.
This tool makes the agent ideal for professional routines that require relentless consistency. Think about tax deadlines, legal filing requirements, or managing a student's highly structured academic study plan.
Compliance routines are a perfect use case. Businesses deal with tasks that repeat daily, weekly, or monthly, and a failure to perform them can incur massive penalties. The automations tool lets the user delegate the maintenance and execution of those compliance tasks entirely.
The specific examples really show its depth. Monthly rent default checking in a property management context, weekly content reminder creation for a YouTube channel, or managing a daily AI study schedule for students. The agent is responsible for executing the workflow on time, every time.
So instead of me having to manually prompt the agent every Tuesday, hey, draft the social media content for this week's video, I would set up an automation that executes a multi-step workflow. The automation could use the Canmore tool to draft the content, the image gen tool to create the thumbnail, the Python tool to pull the analytics from last week, and then it just sends me a notification that the full package is ready for my approval.
It manages those recurring workflows, sends periodic summaries, and ensures that complex, multi-stage plans stay on track without human intervention until a decision point is reached. This shifts the user's role entirely. You go from actively managing the timeline to simply approving or adjusting the outputs generated by the automated workflow. This saves a vast amount of mental energy and ensures deadlines are never missed.
That brings us to the final, and I think most critical layer, the control layer. This addresses the deep personalization, the external connectivity, and the essential ethical and legal guardrails that are required for an agent to truly function as a trusted, high-stakes partner in the real world. I mean, without control, an agent is just a powerful risk.
And the bio tool is where personalization gets really serious. This is not just temporary session memory. This is personalized long-term memory storage. It remembers you, your business context, and your specific requirements over time. This is essentially the AI's version of persistent system instructions.
So it's not just recalling my name. What exactly does this long-term memory store to ensure that consistent professional quality?
It stores the deep characteristics that ensure consistency. Your preferences regarding length, tone, structure, technical jargon, and crucially, maintaining a consistent brand voice or writing style. This prevents the agent from sounding like a different person every single time you interact with it.
The application for massive long-tail projects is absolutely key here. If you're an author working on a series, the source material mentions managing 55-plus book titles. The bio tool ensures that the agent remembers specific character lore, unique terminology, narrative arcs, and stylistic choices across that entire volume of work. It prevents continuity errors, which would be, impossible for a standard context window to handle.
And in high-stakes professional fields, consistency is vital. Imagine a legal firm using the agent to draft arguments across multiple related cases over 2 years. The agent needs to retain a specific, highly formal style, and it needs to recall facts and precedents that were established months ago in previous filings. The bio tool provides the continuity required for the agent to evolve from a session-based tool to a genuine, ongoing organizational partner.
Without the bio tool, every single interaction would start from zero. You would be constantly repeating instructions about style, about background, about specific requirements. This tool must drastically reduce the overhead and training required for the agent to function effectively on massive, long-duration tasks. It makes the agent truly your expert.
The API tool is arguably the central nervous system that transforms the agent from a sophisticated internal engine into a centralized business orchestration hub. This is how the AI agent connects to the external world of proprietary applications, databases, and business systems.
Yeah, this has to be the true unlock for enterprise adoption because businesses don't operate in a vacuum.
Yeah.
They operate across CRMs, ERPs, accounting platforms, and proprietary web services. The API tool lets the agent access external infrastructure. It's the bridge to mobile apps, web apps, and critical backend services.
Exactly. This capability turns the AI agent into an execution layer that sits on top of your existing infrastructure. We're talking about running advanced workflows that involve reading data from one external system and then writing output to another.
The examples in the source are highly specific, like real-time tax filing via the FBR API or AI CRM automation. For our global audience, FBR stands for the Federal Board of Revenue in Pakistan. It's a national tax system. Why is using a specific national tax interface such a powerful example?
It illustrates the point perfectly. It's not just about generalized web searching. It means the agent is capable of interacting with a highly specific, security-conscious, and often labyrinthine governmental digital interface. The agent could take user input, format it according to the specific technical requirements of the FBR API, execute the login and submission process, securely handling something like oath, for example, and then initiate an action outside the agent's environment, the actual filing of a tax document.
That raises a critical challenge, though, security and latency. If the agent is acting on my behalf using an API, how is that security handshake handled? And what happens if the third-party API changes its schema or experiences latency?
That's where the engineering effort is really concentrated. API interaction requires sophisticated security protocols, often using tokens generated through standard oath workflows. The agent is responsible for managing these tokens securely and applying the correct authentication headers. Furthermore, advanced agents include logic to handle common API failures, recognizing rate limits, schema changes, or latency issues, and then reporting back to you instead of just failing silently.
So a business analyst could use the agent to orchestrate these really complex sequences. Maybe use the web tool to gather current sales data, the Python tool to run a profitability analysis, and then use the API tool to automatically update a lead status and schedule a follow-up in the company's third-party CRM system.
What's so fascinating is that the API tool means the agent is no longer limited by its own sandbox. It becomes a centralized control hub, orchestrating and managing activities across all these disparate software platforms, defining a truly integrated business process.
So what does this all mean? We have a powerful, automated, connected, and personalized digital worker. But with that immense power, especially when it's integrated into sensitive systems through the API tool, comes the critical issue of responsibility and liability. This is where the Guardian tool steps in, handling the safety, legality, and policy compliance of the agent's output.
The Guardian tool is the essential ethical and compliance layer. You can think of it as the AI's internal legal and policy review board. Its sole purpose is to ensure that outputs remain safe, legal, and policy compliant before they are ever released or acted upon, especially when the stakes are high.
So this means there are active real-time checks running in the background, detecting risky content and enforcing organizational policies. Can you give some specific examples of the types of checks it performs?
In high-stakes, regulated environments, like legal, medical, or financial, this is just non-negotiable for minimizing liability. For example, the tool prevents the generation of unauthorized medical advice or professional diagnoses, making sure the agent doesn't overstep its defined boundaries. If you prompt it for a financial product recommendation, the Guardian tool checks that the response includes all the required disclosures and avoids providing regulated advice it is not licensed to give.
And it also validates political or religious sensitivities, I see. So it prevents the agent from creating content that could be interpreted as biased political influence or culturally inappropriate messaging, which is absolutely crucial for international brands or organizations that are dealing with diverse audiences.
This enforces a safety-first corporate workflow. If a business is using the agent to draft external communications or internal policy using the Canmore tool, the Guardian tool acts as an automated review board, operating within defined organizational policies. It ensures the content is not only accurate, but also defensible and compliant with external legal standards and internal corporate governance.
This layer is so crucial for building trust. It tells the user that while the agent is fast and powerful, it is also operating within strict, necessary guardrails. It shifts the burden of continuous compliance checking from the human user to the automated agent. It's powerful to see these tools individually. I mean, they're incredible capabilities on their own, but the real magic, the true definition of an AI agent as a no-code development platform, is when these 10 capabilities stop acting as separate features. It's when they combine into a unified, synergistic workflow. This is really the narrative climax of our deep dive.
This integration is the absolute key. The agent's intelligence is measured by its ability to select and chain the correct tools in the correct sequence to achieve a complex multi-stage goal. You simply define the goal, and the agent orchestrates the entire chain of execution.
Okay, let's walk through the detailed example provided in the source material, the legal case agent workflow. We're talking about an attorney using the system to prepare a critical document. We need to follow the data as it moves through the entire ecosystem of tools we just discussed.
Okay, so the process starts with the information intake. It uses the file search tool to extract the initial case facts, previous judgments, client testimony, and internal correspondence uploaded by the legal team. The agent uses its RAG architecture to deeply analyze these documents, identifying key clauses and precedents.
So the agent now has the foundational facts, but those facts need to be validated against the current legal landscape.
Exactly. The agent immediately leverages the web tool to check for the latest, most recent judgments relevant to those specific facts and clauses it found in the document set. This ensures the legal argument is grounded in current law, solving that knowledge cutoff problem and verifying the status of existing rulings.
Next, we have to move into the computation and structuring phase, because raw citations and facts need to be organized for a professional brief.
The Python tool is engaged here. It takes the factual information from file search and the current citations from the web tool, and it's instructed to generate a structured table of key citations, dates, jurisdictions, and extracted data points. This moves raw information into a usable, organized legal asset, maybe an auditable CSV that can be cross-referenced by the legal team.
Once that structured data and research exists, it needs to be integrated into the final document, which is going to be long and complex.
So the agent uses the Canmore tool, its internal long document workspace, to take the extracted information and create a full, structured legal argument or draft, like a motion or a detailed writ petition. And crucially, Canmore maintains consistency, formatting, and version control throughout the process, even if the drafting spans several weeks.
And as the argument is being drafted, that control layer is always running in the background. The Guardian tool is actively checking the output of the Canmore draft to ensure that no unauthorized or non-compliant legal language is used, preventing procedural errors or overstepping ethical boundaries.
And furthermore, the bio tool is ensuring that the tone and the highly formal structure of the argument align with a specific style preferred by the senior partner, who the agent has worked with for months. This ensures brand and stylistic consistency across all external filings.
This is truly a unified operation. And finally, the task needs ongoing maintenance.
The automations tool is set up to schedule the next necessary action. Maybe a research update for a week later, a reminder to check the court docket, or a filing reminder for the final petition. And if the brief needed a visual appendix, the image gen tool would be called upon to create a relevant flowchart or organizational diagram to explain the facts to the judge.
That is a phenomenal example of orchestrated delegation. In a single workflow, the agent moved from reading complex proprietary files and searching the public internet to calculating, structuring, writing, formatting, ensuring compliance, and then scheduling the next action, all without the user needing to manually transition the data between 10 different pieces of software.
And if we just summarize the core contribution of each tool, we see the complete picture. The web tool provides real-time, verified external knowledge. Python enables auditable computation and structured file generation. Canmore is the long-form, structural writing workspace. Automations handle scheduling and proactive maintenance. ImageGen adds professional visuals and diagrams. File Search provides deep document intelligence via RIG. Bio ensures personalized, consistent, long-term memory. The API tool enables external integrations and action execution. And the Guardian tool wraps it all in a critical layer of safety and compliance.
Together, these 10 capabilities truly transform the AI agent from a simple text model into a functional, comprehensive, and ultimately a complete no-code AI agent development platform. You're not writing code, you're just chaining capabilities.
The scope of change this architecture represents is, well, it's profound. We're moving beyond the era where the user was a prompt engineer, struggling to craft the perfect conversational query to get one answer. The user is now a workflow designer. You are outlining the steps, integrating these tools, and delegating the end-to-end process to the agent.
That's the defining shift. You're delegating complex, multi-step tasks to a single digital worker who handles research, data analysis, document creation, and task management across multiple domains. It's moving beyond asking the AI for help and moving into telling the AI what entire job to execute. So we'll leave you with this provocative thought to mull over, which gets right to the heart of future professional value. If an AI agent can seamlessly handle the entire workflow, from gathering proprietary data with file search and running complex analysis with Python, to creating multi-volume documents with Canmore and maintaining the schedule with automations, what are the high-level human skills you will prioritize and focus on when complex execution is delegated? When the process of doing has been outsourced to the designer of the process, what is the irreplaceable human function?